Hello everyone, and let's look at the solutions of chapter 4, and that is logarithms and exponential functions. So let's start with the first question. Now in this question, this is an exponential equation. Now such questions, as I told you in the theory video also, that we try to take terms common and then solve it, right? So the way we can proceed with this question is, we have 9 to the power 2x minus 1 and 81, right? So the first thing that I can do is I can first change it to a common base. So 9 is a power of 3, which is 3 square, and 81 also comes in a power of 3, which is 3 to the power 4. So let's first convert that. So 3 to the power 2 into 2x minus 1 is equal to, sorry, minus 3 to the power 4 into x minus 1 is equal to 1944. So this is how I can do it. So I will be getting 3 to the power 4x minus 2 minus 3 to the power 4x minus 4 equal to 1944. Now I know out of 4x minus 2 and 4x minus 4, 4x minus 4 is a smaller value. So I can take 3 to the power 4x minus 4 common. Now I know what will be left here. In order to get 4x minus 2, right, what should I add in 4x minus 4? I should be adding 2. So I'll be left with 3 square. Minus 1 is equal to 1944. Now once I've got this, I will be left with, this is 9 minus 1, which is 8, equals to 1944. And finally, I'll be getting 3 to the power 4x minus 4 is equal to, if I divide 1944 by 8, I will be getting 243. And 243, as I know, is 3 to the power 5. Right? So powers should be remembered. One should remember powers, right? Of 2 to the power 12, till 2 to the power 12, and 3 to the power 8, and for rest of the numbers till 5. One should remember these values. It's very helpful. So this is 3 to the power 5. So 4x minus 4 is 5. So x will be 9 by 4. 9 by 4 is the correct answer to this question. Right. Let's see. Yeah, 9 by 4. Now let's move on to the next. Now next again, as I can see on the left hand side, we have 9 to the power something, 2 to the power something. On the right hand side, we have 4 and 3's. Right. So the common powers, common bases of the exponents can be converted into 3's and 2's. So if I write this as 3 to the power 2 x minus half minus 2, let it be this only, and here I can write it as 2 to the power 2x minus 3 to the power 2x minus 3. So I can very well keep it like this. Now it is advisable that I bring all the terms with exponent, with the base of the exponent being 3 together and base of the exponent being 2 together. So I can do this, 2x minus 1 plus 3 to the power 2x minus 3 equal to 2 to the power 2x plus 2 to the power 2x minus 2. So this is something which I can do. I can can collect all the threes, 3 being the base of the exponent together and 2 being the base of the exponent together. Now I know the smaller value among 2x minus 1 and 2x minus 3 is 2x minus 3. So I can take 3 to the power 2x minus 3 common. So eventually I will be left with 3 to the power 2 plus 1. And here I can take 2 to the power 2x minus 2 common. So I'll be left with 2 to the power 2 plus 1. So if I further solve it, I will be getting 3 to the power 2x minus 3, right, into 10 is equal to 2 into 2x minus 2 into 5. So this cancels to 2, and if I bring the 2 in the denominator, so I will be left with 2 to the power 2x minus 2 upon 2, which will further give me 3 to the power 2x minus 3 equal to 2 to the power 2x minus 3. Now this is a very peculiar condition, as in powers are equal, so bases should be equal. This is what I know. But then I told you one exception. The exception is the two values can be equal if their powers are 0, despite the bases are not same. So the bases are not same, but the powers are equal. So the values can only be equal if the power becomes 0. So if I say 2x minus 3 is 0, so x is 3 by 2. So that becomes the right answer. So x is 3 by 2, right? So answer to this is 3 by 2. So the at the end, or just a quick, just to remind, why have we done that? Since the powers are same, bases should be equal. Then only the two exponents value are equal. But since the bases are not same, but the powers are same, so I can only solve this if the power is 0. Then only the bases are not same. Even though the bases are not same, the values of exponents will be equal. So that's why I put the power 0. So it gives me x equal to 3 by 2, which is the right answer. Okay, let's move on to the next. Now this is based on logs, right? Now, whenever we have such values which are equal to each other, and then they are asking the value of log in base as PQR. Now I know a property of log, that log a with the base a is 1. So that's only how I can remove the log. So the base is s. So it is imperative that I convert PQR in terms of s, and that I very well I can do. So p cube is s to the power 6. So I can write down p as s to the power 6 whole to the power 1 by 3. So it becomes s square. Similarly, if I say p to the power 3 is r to the power 5, so I can write p as r to the power 5 whole to the power 1 by 3. Right? Just a minute. Sorry. I have to convert everything in terms of x. So let's leave it apart. So q to the power 4 is s to the power 6. So q will be s to the power 6 whole to the power 1 by 4. And then r to the power 5 is s to the power 6. So r will be s to the power 6 whole to the power 1 by 5. So this is what I have obtained. I have obtained the values of p, p, q and r in terms of s. Now since I have to find the value of log of base s p q r, so I'll just substitute the value log base s. P is s square, q is s to the power 3 by 2 and r is s to the power 6 by 5. So if I add the powers, I will be getting 2 plus 3 by 2 plus 6 by 5. LCM is 10, so it's gonna give me 20 plus 2 tens are, so 2 5s are 3 5s are 15 and 5 2s are 12. So this will give me 47 by 10. So this will be log s to the power 47 by 10. So my answer will be 47 by 10. So if I bring it here, m log s property, right, log s, right, s to the power m can be written as m log s base s. So this becomes 1, so that's why the answer will be 1. So in this case, the answer will be 47 by 10, which is C option. So this is the right answer. So this is how we can do these kind of questions, right? Let's move on to the next. Next question again is interesting, and these are two equations, two variable type questions, but given in the exponent form. So I can change it to linear form and then I can solve it. There's one way. Other is if we remember the powers of 3s and 5s, then also we can do it. First, I'll tell you the conventional way of doing it. So 5 to the power x minus 3 to the power y is 13438, and I can write 5 to the power x upon 5 plus 3 into 3 to the power y as 9686. Now the first thing is I will be putting 5 to the power x as say a and 3 to the power 5y as b. So I'm going to get two equations. A minus b is 13438 and the other equation is a by 5 minus 3b is equal to 9686. Now I have to find the values of a and b. So I'll solve them simultaneously. So what I can do is I can multiply by 3 and subtract, or let's keep fraction. So let's multiply by 5 and subtract. That will be a bit better. So a minus b will be 13438, and here a minus 15b will be 343, 434 and 48. Okay, so this will be it. Okay, now if I subtract, right, sorry, this is plus, sorry, my bad, right. So if I subtract, I'm gonna get minus 16b is equal to this will be okay, or if I subtract, I'll get, suppose I'm subtracting 1 from 2, so 16b equal to 2, 9, then it will be 9 again, 9, right, and then it will be 4 and 3. So b becomes equal to 34992 divided by 16, which will give me, if I cancel by 4, so it will be 8, right, 7, 4, 8 divided by 4. I can still divide by 4, which is 2, 1, 8, 7. Now 2187 is nothing but 3 to the power 7, right? So b was 3 to the power y, and this is 3 to the power 7. If I remember my powers, so it's very easy for me. 3 to the power 6 is 729. This is 729 into 3. So y becomes 7. Right. So, but I have to find the value of a also. So how will I find the value of a? I know a is equal to 13438 plus b, and b came out as 3499. Sorry, b was 2187. So I'll say 2187. If I add it, so I'll get 5, then I'll get 12, then I'll get 6, then I'll get 5, then I'll get 1. 15625 is nothing but 5 to the power 6. So if I remember my powers of 5 till 6, so it is easy for me to identify with it. So 5 to the power 6. So, and a was 5 to the power x. So x becomes 6 and y becomes 7. So answer will be 7 plus 6, which is 13. So 13 is the right answer. So this is how I can do this problem. But yeah, simultaneously and understanding the process and everything, it's very important. But then I can also do this question by intuitively, like initially only I know it's a 5-digit number, so I have to check for a power of 5, which gives me a 5-digit number. So again, if I remember, like 5 to the power 6 is 15625, right? So if I remember this, and if I also remember 3 to the power 7 is 2187, and if I subtract 15 minus 7 is 2, 11 minus 8 is 3, 5 minus 4, 3. So 1, 4, 3, 4, 3, right? Sorry, 8. Right, 1, 3, 4, 3, 8 is what I get. And the moment I get the value of x plus y is 13. Right? So this also you can apply, provided you know the powers of the numbers. From 2, for 2 you should be knowing the powers till 12, for 3 you should be knowing till 8, for 5 you should be knowing till 6, for every other number you should know till 6. It's a must. 5 or 6 is something which you can look for, right? So let's move on to the next. Okay, now here I need to find this expression is given to me, and I need to find the value of 1 by x minus 1 by y. Now powers are in x and y, so it is imperative that, and since there's a similar, number is same, only the decimal is decimal applied is uh, you know, one differently, but numbers are, as a number, if I look at it, I can see 555 very vividly. So if I say 5.55 is nothing but 1000 to the power 1 by x, so I'm getting somehow, 1 by x as what I need. So 0.555 will be 1000 to the power 1 by y, as I can see. Now, if I divide the two equations, so what will I get? So it is, or I can write it as 555 by 100 equal to 1000 1 by x. Let me simplify this a bit, and 555 upon 1000 is equal to 1000 to the power 1 by y. So this is, I can approach this problem. Now if I divide, 555 will get cancelled, so it will give me 10 equal to 10,000 1 by x minus 1 by y on dividing the two equation. Right, 555 will get cancelled, 10 will go up, and this will be 1000 to the power 1 by x minus 1 by y. Now I can write this as 10 to the power 3 1 by x minus 1 by y. Now if I equate, to 3 1 by x minus 1 by y is 1. So finally I will get 1 by x minus 1 by y as 1 by 3. That's the right answer, and that is what was required. So once I've done that, I will be getting this easily. This is the right answer. So I hope you have understood this, right? Okay. Now let's move on to the next question. Next question is x equal to 4096. 4096, if I remember the power of 2 till 12. So this is 2 to the power 12. So that's where it is very, very important to remember the powers in exponents especially. So then, and 64 is 2 to the power 6. So 2 to the power 12 is this. I need to somehow relate it to 2 to the power 6. The moment I can identify these two numbers as a power of 2, my solution will become easy. Else I have to, this can be a very tricky question. Now I know 4096 is nothing but x to the power, this is 4 root 3, x to the power 1 upon 7 plus 4 root 3. Now the moment I see this, I get 2 to the power 12 is equal to, now if I rationalize the denominator, which I should do if it is an irrational number, so I'm going to multiply by conjugate, right? The moment I do that, I will be getting equal to x to the power 7 minus 4 root 3. Because a plus b, a minus b, if I apply, so I will be getting 49 minus 48, a square minus b square. 49 minus 48 will become 1. So if this is 2 to the power 12, then 2 to the power 6 is nothing but I'll take the root of it. Right? So this finally gives me 2 to the power 6 as, which is 64, as x to the power 7 by 2 minus 2 root 3. Now if I look at my options, so this C is the right answer. 7 by 2 minus 2 root 3. That becomes the right answer. So remembering the powers in exponent problems is very, very important. If one can do that, the solutions will be far easier, right? Okay, so now let's move on to this question. So it says that root of 7 by 5 to the power 3x minus y is equal to 875 upon 2401, and there is another relation as well. Now there are two equation, two variable type problem. This reckons to be, right? So first of all, I'll say 7 by 5 3x to the power 3x minus y by 2. This is what I have done. Now, can I just see if I can reduce this? 2401 I can say is 7 to the power 4. So I have to just check whether the numerator is divisible by 7 or not. So if I look at it, so it gives me 1's a 2, 125. Yes, it gets cancelled, it's 343. The moment I get this, so it becomes 5 by 7 cube. Or I can also say 7 by 5 to the power 3x minus y by 2 is nothing but 7 by 5 to the power minus 3. So I've got a relation which gives me 3x minus y by 2 is equal to minus 3, and 3x minus y equal to minus 6. This is one relation I've got. Right? Now the second is from the second one. This gives me, now if I look at carefully, the power is same, just that the sign is different. So 4a to the power 4a by b to the power 6x minus y, I can write it as b by 2a 6x minus y, just by taking out the minus sign common, and then I can reverse. 2a by b to the power minus 1 will become b by 2a to the power 1, right? But now here again the powers are same but the bases are not. That means that is only possible when the power is 0, as we have seen in the previous problem. So this is equal to 0, so I get y is equal to 6x. I can put it here, 3x minus 6x is equal to minus 6. So minus 3x is minus 6, so x is 2. X is 2, y is 12. So I have to find the value of x plus y, which is 14. So this is how I can solve these problems. So these equation type problems are is essential part of TMUA, right? So just we should know how to solve them, right? Let's move on to the next. Now this is a logarithm problem. Find the sum of all possible values of x for the equation. Now, in such cases, what we need to do is, I have to change this log form to exponential form, as I've told you in the theory video. So, x minus 1 squared will give me 3. This will go here, this will go in the power, and log will disappear. So, x minus 1 whole square is equal to 3. So, x minus 1 will be plus minus root 3. So, value of x will either be root 3 plus 1, or it will be minus root 3 plus 1. Now, the base of the log cannot be 1 and has to be positive. Now, if I take this value, then the x minus 1 will be positive, because root 3 plus 1 is a value greater than 1. But if I take this value, which is already negative, so negative minus negative will be less than 0. So minus root 3 plus 1 minus 1 will be less than 0, as I can see very easily. Minus root 3 is less than 0. So the only possible value of x which I can take here is root 3 plus 1, right? So the answer will be B. So very easily I can solve this, right? So sum of the values only will be 1 only, so root 3 plus 1 will be the answer. Sometimes we tend to think both are the answer, and if I sum up the values will be 2. So 2 is also there in the option. We need to be very careful with this. Okay, so now let's move on to this problem. This is a logarithmic equation. So first of all, when no base is given and we have log written, the base is 10. You must argue, you can argue, sir, okay, the base can also be e when there is no base given. But in that case, it will be written ln5. So if it is written ln5, then I'll say natural log, which is log of base e, otherwise 10. So now whenever this 1 is there, so I can write it as log 10. Why? Because we have to reduce them to a single log by applying property of log a plus log b or log a minus log b. So I should write 1 as log 10. Now this will give me log 5 into x plus 10 upon 10 is equal to log of 21x minus 20 upon 2x minus 1, which will further, if I reduce it to 2. So if two log values are equal, then the numbers of whom I'm taking log of will also be equal. So x plus 10 by 2 is 21x minus 20 upon 2x minus 1. This is what follows. So it gives me 2x square minus x plus 20x minus 10 is equal to 42x minus 40. which will further give me 2x square. 19 minus 42 will give me 19, 23. So minus 23x, right? And plus 30 equals 0. This is what I eventually have got, right? Now I can calculate roots of it, right? Um, or I can use, since I have to find x minus 2, x1 minus x2 mod. So I know x1 plus x2 from this equation is 23 by 2, and x1 x2 is 30 by 2, and I know that x1 minus x2 square is equal to x1 plus x2 whole square minus 4x1 x2 by using the expansion. So it will give me 529 by 4 minus 4 into 120 by 2, right? 120 by 2. So which will further give me x1 minus x2 square is equal to 529 minus 240 will give me 9, 8, 289. 289 by 4, which will be 17 by 2, the root of which. So x1 minus x2 will be 17 by 2, which will be 8.5. So answer is 8.5 is the right answer. So this is how we can proceed with these kind of questions, right? A lot of times such questions have come in TMUA, right? So let's proceed further. So it gives me again a similar kind of a equation, but now there are two equations. So I have to look for the common solutions of these two, and then we have to sum it up. So first let's solve. So root of 5 minus x into 2 will be equal to x plus 3, applying the property here. So it will, and squaring both sides will give me 2 into 5 minus x is equal to x plus 3 whole square, and x square plus 7x minus 8 equal to 0 will give me roots a minus 8 and 1, which I can easily calculate. Now this gives me x square plus 9 plus 6x minus 20 plus 4x equal to 0. So this is again another quadratic, right? So I will be getting x square plus 10x 10x minus 11 equal to 0, which will give me roots as minus 11 and 1. Minus 11 and 1. So these are the values of x. Now the common value in these two is 1. So 1 is the right answer. So there is only one of them. So answer has to be 1 only. So this is how we can do these kind of problems. Let's move on to the next. Again, two equation, two variables. So exponential 2 to the power 2 x plus y is 128, which is 2 to the power 7. And 5 to the power 3x minus 2y minus 3 is 1, which is only possible when the power is 0. So I've got this relation, and I've got 2x plus 2y equal to 7. So two equation, two variables I have to solve. So this gives me 3x minus 2y equal to 3. So if I add, I get 5x equal to 10. So x is 2. So if x is 2, y will be, if I put x as 2, so let me, 2x plus 2y is equal to 7. So 2y is equal to 7 minus 4, which is 3. So y will be 3 by 2. And I have to find the value of x into y. So 3 by 2 into 2 will give me 3. 3 is the right answer. So you have to understand what we have to calculate at the end. So these kind of system of equations are pretty much integral part. Let's do another one. Find the value of x by y for the following system of equations. Log x base 2 plus 2 log y base 2 is 3. So if I again combine, so it will give me log x base 2 plus log 2y square equal to 3. So log x y square base 2 is 3. This is what I've got. So I've got an equation xy square is equal to 2 to the power 3. If I change it to the exponential form, so xy square is 8. So this is one equation I've got, and the other equation is x square plus y to the power 4 is 16. Right. Now, the thing that I need to be careful about is this is degree 4, right? So, I know that y square is 8 by x. So, y to the power 4 will be 64 by x square, squaring both sides. Now, the moment I put this here in this equation, I'm going to get x square plus 64 upon x square is equal to 16, which will give me x to the power 4 plus 64 equal to 16x square, and this further will give me this. Now if I look at this carefully, so this is a whole square of x square minus 8. So the value of x square is 8. So value of x square is 8. So value of uh, y square will be uh, okay, will be root of 8. Y square will be root of 8. This is what I will get. Right. So the value of x will be plus minus root of 8. Now the only thing question is, can I take it minus? No, I cannot, because here x has to be greater than 0 and y greater than 0. So the only value I'll take is root of 8. Right. And the value of y will be again 8 to the power 1 by 4. 8 to the power 1 by 4. I cannot take the negative value because it's under the root. So you have to be careful. Right. So now they're asking the value of x by y. So x is 8 to the power half and y is 8 to the power 1 by 4. So final answer will be half minus 1 by 4, which will be 1 by 4. So answer is 8 to the power 1 by 4, which is the correct answer, B option. This is how we have to proceed with these kind of equations. What we can do then, right? Okay, another two equations. It gives me log base x square plus 12 is equal to 4, and 3 log x base y is 1. So first equation gives me x square plus 12 is equal to x to the power 4 if I change it to the exponential form. Right, and the other equation gives me y is equal to, I can write this as equal to 1 if I apply the property of m log a, and this finally gives me, this is the base, sorry, so x cube will be y. These are the two things that I've got, right? So this equation is x to the power 4 minus x square minus 12 equal to 0. Now the roots of which, here the roots will be basically x square. So the x square values here will be 4 or minus 3, but I cannot take minus 3 since it's a square value. So x will be plus minus 2, and I need to check x is positive real number. So I'll take only x as 2, x is 2, and x cube is y, so y becomes 2 cube, which is 8, and I need to find x plus y. So 8 plus, right? So it will be 8 plus 2, which is 10. So 10 is the right answer. Right? So this is how we can do this problem. Let's move on to the next. Okay, so let's move on to this question. So it says that x and y are positive real numbers such that log base 5 x plus y plus log base 5 x minus y is equal to 3. Now this equation will change to x plus y into x minus y is equal to 3, which if I change to the exponential form will give me x square minus y square equal to 5 cube. Now the second equation is log y base 2 minus log x base 2 equal to 1. 1 I can write it as log 2 base 2 since the base is 2 minus log 3 base 2. Now this gives me log base 2 y by x is equal to log base 2 2 by 3. So I've got the value of y by x as 2 by 3. This is what I have got, where I will get the value of x as 3 by 2 y. This is eventually what I've got, and I can substitute this value in this equation here. So it gives me 3 by 2 y square minus y square is 125. So this gives me 9y square by 4 minus y square is 125, which gives me 5y square equal to 500. So y square is 100, so y is 10 since y is positive, and x is 3 2 into 10, which is 5, 15, and I need to calculate the value of x into y. So x into y will give me 150. So right answer is 150. So 150 becomes the right answer. So again, two variables and two equations. Mostly these kind of questions comes in TMUA. Now let's move on to the next. Now it says that I have an equation 81 to the power log x base 10 equals 3 plus 2x log 9 base 10. Now this is a little higher on the higher side, this equation. This TMU equation will be 19th, 20th level question. Right. Now by observation, there is something very unique in logs. Like I'll just tell you one thing. A to the power log b in base c is same as b to the power log a in base c. Why? How? I can prove this. So if I take log of both sides with base c, so I will be getting log b base c, m log a property, log a base c, and log a base c, log b base c. By taking log with base c on both sides, you can see left hand side will be equal to right hand side. So means to say, if I change these two, right, the value doesn't change. It remains same. So on this observation, I have 9 to the power 2 log x base 10. I've written 81 as 9 square equal to 3 plus 2x 9 base 10. Now, if I interchange these two, right, so 9 log x base 10 whole square. I can write it like this using the property of indices. This 2 can be written as whole square because log m whole to the power n is nothing but log mn. Sorry, a to the power m whole to the power n is nothing but same as a to the power mn, which is equal to 3 log 3 plus 2 9 log base 10x. I can write this like this. Just told you. Now, if I put this entire thing as say t, 9, I'm putting 9 log base 10 x, the entire thing as t, sorry, 9 to the power log x base 10, entire thing as t, so it becomes t square equal to 3 plus 2t. So this gives me further t square minus 2t minus 3 equal to 0. The value of t will either be 2 or, sorry, 3 and minus 1. 3 and minus 1. Now that I know t is an exponential value which can't be negative. So 9 log x base 10 is equal to 3. Now I can write 9 as 3 square. So 3 log x base 10 equal to 3. So log x base 10 is equal to 1, 2 log. So log x base 10 is equal to half. X will be 10 to the power half. Right. So this is the only value that I can have. So the number of real values satisfying this will be only one. Only one of them will satisfy. Right. So a little on the higher side, but still we can do this. Okay, let's do this one. It says that find the number of solution values of x that satisfy. Now I've told you one property, a log b to the base a is b only. I covered this in the theory video. So using the same, if I use the same property, I get 2. I can write 27 as 3 cube log base 3 log x base 4 is same as the same log x base 4 whole square plus 5 log x base 4 plus 2. Now if I bring this 3 here, so using this property, this becomes 2 log x base 4 whole square equal to log x base 4 square plus 5 log x base 4 plus 2. Now you can see if I put log x base 4 as suppose t, so this becomes a cubic. This is 3, sorry. This becomes a cubic 2t cube minus t square minus 5t minus 2 is 0. And then we have to calculate roots of this. So I know the process. First is through hit and trial. So let me put 1. 1 if I put, it will not satisfy. If I put minus 1, then it will minus 2, minus 1, plus 5, minus 2 is 0. So one of the root is minus 1. And then we can apply synthetic division methods. So 2 minus 1 minus 5 minus 2. This I've covered in polynomials, right? So 2 minus 2 adding minus 3. Minus 3 into minus 1 is 3. Adding is minus 2. Then multiply minus 2 by minus 1 is 2, which is 0. So finally, the other two roots will be 2x square minus 3x minus 2 equal to 0. So this will be 2x square minus 4x plus x minus 2 equal to 0. So I'll get one of the root as 2 and the other as minus half. So the three values minus 1, 2 and minus half. And log value can be negative. So all three are possible. But having said that, very important point, this log was also inside another log, and log of negative number is not defined. So if I t is the value of log x base 4 and log x base 4 is inside another log, so log x base 4 cannot be negative. So if it can't be negative, so minus 1 and minus half will be discarded. So it will have only one solution. So this is how we go about these problems. So all of them are very important problems. Just go through them once again, right? I'll come up with the next video. Till then, take care. Have a nice day.